Good morning and welcome everyone. My name is Pranav Parikh and I work as an engineer at Walmart. Today I am here to talk about Walmart's journey to build a scalable testing infrastructure using Concord and Kubernetes. From our humble beginnings as a small discount retailer in Arkansas, Walmart has opened thousands of stores in the US and expanded internationally. Through innovation, we are creating a seamless experience to let our customers shop anytime and anywhere online, through mobile devices, and in stores. Our long serving mission has been to help customers save money so they can live better. We are passionate about our mission, and every technology we create is built to serve our customers. Walmart culture is built on four beliefs: service to the customer, respect for the individual, strive for excellence, and acting with integrity. These beliefs have been the recipe for our success for many years. Our culture is the reason we have been able to grow on a global scale and help our customers. Talking about Walmart, we need to think about the scale. Walmart operates more than 11,000 stores worldwide, serves about 265 million customers online and in stores every week, and employs 2.2 million associates around the world. And Walmart has a significant presence in the e-commerce world as well. To achieve this kind of scale, numerous small and large software systems work in tandem, and to ensure that we can successfully deploy any changes to the systems in an efficient and timely manner, we need a robust deployment system in place. So what do we use for deployments at Walmart? Let's see. The answer is Concord. Concord is a standard tool used to facilitate continuous delivery and deployments at Walmart. It's an open sourced software from Walmart meant for workflow orchestration. Although its primary use case is to help with continuous deployments, it can be used for any kind of process automation. Concord is an orchestration engine that connects different systems together using scenarios and plugins created by the users. The main components of Concord are server and agent. Server is the central component which provides the APIs used to control processes, manage entities such as projects and secrets. Agent is responsible for process execution. It receives workload from server and, depending on the configuration of the job, starts the processes in separate JVMs and or Docker containers. A single agent can run one or more jobs simultaneously depending on the configuration. It is possible to have agents with different capabilities like different hardware configurations connected to the single Concord instance. In addition, Console provides user interface for managing processes, projects, secrets, and other entities. A process is a basic entity in Concord. A process is an execution of a workflow in isolated environment. It can run in a project and can share configuration and resources with other processes in the same project. Projects are a way to group up processes and use shared environment and configuration. Concord provides an API and a plugin as well to work with secrets such as SSH keys, username password pairs, API tokens, etc. Organizations are namespaces to which resources such as projects, secrets, teams, etc. belong to. And there are numerous plugins available as part of the Concord ecosystem, as well as users can write their own custom plugins. Concord is proven to work at Walmart scale, running thousands of deployments and workflows every single day. It can be used to deploy your apps on mainframes, containers, virtual machines, Kubernetes, and on any other stack. Concord provides YAML-based domain specification language. It supports a plugin-based architecture where users can write their own custom plugins for different scenarios. And any kind of process automation can be achieved with Concord. Concord allows to work with secrets like API tokens, database passwords, etc. in a secure manner. The UI allows to build custom forms as per the user requirements. Concord comes with multi-tenant user interface and access control, and provides LDAP integration. Concord is PCI compliant, and it also supports JSR scripting where users can run the scripts written in languages like JavaScript, Groovy, Python, etc. as part of their Concord workflows. Plugins. Concord operates on a plugin-based architecture, and it has various plugins available for commonly used tools and services such as Ansible, Docker and Kubernetes ecosystem, CI, OneOps, email, Slack, LDAP, as well as Git and Jira. Users can also write their own custom plugins to integrate with an internal service or for other similar use cases. What are the workflows supported by Concord? Whatever you define using the Concord domain specification language in YAML, scripting using languages like Python, JavaScript, Groovy and JRuby, as well as any flow using the inbuilt or any custom plugin written by a user. What are some of the most common workflows we see on a day-to-day basis? Common examples are infrastructure provisioning and management and CI/CD pipeline orchestration. Let's take a look at how you can write a simple Concord workflow. In this example, I want to use Ansible, so I add the Ansible task as a Maven dependency in the configuration section. All the flows should go under the flows section. If I don't specify which flow to run, Concord looks for a flow named default and runs it. Since I want to run Ansible task, I add task as Ansible. In specifies the input to my task. Playbook is my Ansible playbook, which just runs a debug task in this case. In inventory, I provide the details of the hosts I want to connect and run my playbook on. In this case, it is just localhost since I am running the playbook on my local. Any extra variables I want to pass to the playbook can be declared in extra vars. When I run this Concord workflow, it will run the Ansible playbook hello.yaml and run a debug task, echoing the greetings I send. Now this is a very simple example to begin with, but you can write complex Concord flows using conditionals, importing from other flows, and define different types of triggers. So far, we saw what Concord is and how we can leverage it for any kind of a workflow orchestration. At Walmart, we believe in delivering quality to the customers, and in this era of cutting-edge technologies, automated testing forms a key component of our CI/CD pipelines. Given the scale we operate at, we also need to make our test infrastructure scalable. So we started looking into some areas in testing where we could leverage Concord. Let me walk you through that journey. Most of us know this theory of test pyramid, which says that the more we test early in isolation, that is write unit tests, the more faster we can deliver quality software. The more early we catch a bug in the process, the more cheaper it is to fix. Personally, I have been saved time and again by the unit tests I wrote from the disaster waiting to happen somewhere in production. But the question is unit testing enough? They sure provide you confidence in your code, but is that it? I think no matter how much unit testing we do, the software we write will still need to be integrated with other systems, and we still need some level of functional or integration testing before we can open it up for the end users. Let me walk you through some of the common challenges we come across in testing very frequently. I personally have run into this many times where my tests passed locally but not on CI. Of course, I used a different hardware and OS on my local, and I found that some libraries I used are not compatible to run in the CI environment. So the next question is, give me a clean and an isolated environment where I can run my tests. For some teams, depending on the complexities, their tests take longer time to finish. Time is very subjective here, but hey, who doesn't want to be fast? Also, for teams running longer tests and thereby consuming a good chunk of CI resources, we need to provide them an alternative way to run their tests. This is another common question we get. Teams deploy their apps using Concord and Kubernetes, and now they want to run some tests against the deployed endpoints. What do they do? Keeping these challenges in mind, we tried to explore different ideas. We knew that we could use Concord to do any kind of workflow orchestration. We were looking at a containerized solution to run the tests and also allow us to scale the test infrastructure, and so Kubernetes and the containers were the right fit for us. As a solution, we wrote a custom plugin on Concord called End-to-End Test Plugin. Let's see how this plugin works. Let's see what a user needs to have to use this plugin. To start with, they will need a Docker image which can run the tests, that is, containerize your tests. You need a way to authenticate to a Kubernetes cluster you want to use, and also provide a namespace where you want to run your tests. Let me walk you through the CI/CD flow to explain how this plugin fits in. A commit to GitHub triggers a CI pipeline which builds the artifacts and Docker images, pushes them to a repository, and triggers a Concord workflow, which will run the end-to-end or integration tests using this plugin. User can manually trigger the CI or Concord flow directly too. Whatever you see within the blue dotted lines is the Kubernetes infra. The end-to-end test plugin takes the user input defined in the Concord flow, spins up a job on Kubernetes using an image called Orchestra, and then suspends the Concord flow. Keep in mind that the Concord agent is used to run a workflow, so when a process is suspended, the agent becomes free and can be used to run some other process. Orchestra registers a Concord hook so it knows which Concord flow it needs to resume after the job completes. If a PR build triggers this job, it also registers a Git hook with the PR build details so it can comment on the PR build status. Orchestra knows from the input what Docker image to pull from the registry to execute the tests the user wants to run. Users might want to run parallel test suites. A common example would be for front-end tests to be executed against different browsers like Chrome, Firefox in parallel. So Orchestra calculates the number of shards users want to run and spins up those many jobs on the Kubernetes cluster. Note that Orchestra runs in the same namespace as the test jobs. In the image, the term BYOC means bring your own container, which is basically the container which the user provides to run the tests. So Orchestra keeps on monitoring the status of these jobs, and once all the test jobs complete, it calculates the overall status of the job based on exit codes of each job and reports it back to Concord. At this time, it resumes the Concord process, which was suspended, so a new Concord agent is acquired, which resumes the flow. This suspend resume mechanism helps us save Concord resources since we don't actively use an agent when a Concord flow is suspended. The build status along with the job summary of each shard can be read in the Concord flow using the context variables. Based on the status, users can choose to continue or halt their CI/CD pipeline. To retrieve all the container logs, users can use the kubectl plugin. The container logs can also be uploaded to a central reporting system for future use and analysis. So this is how the plugin works in a CI/CD pipeline. To use the plugin, add the Maven dependency in the configuration section. As inputs to the plugin, one is action, where start is the only supported value for now, and parameters, which consists of runner and test. Runner contains the information pertinent to Concord and Kubernetes, and test has the information for the tests. Let's see them in more detail. Runner. The runner section supports following fields. Cluster. This is your Kubernetes cluster. Namespace. A namespace on the cluster where you want the job to run on. Cluster certificate. You can use the cluster certificate to authenticate to Kubernetes if you have one. We use the DEX authentication mechanism and we get the client ID, client secret, redirect URL, base URL information from our cluster administrators. You can specify the maximum and minimum memory capacity to allocate for the job, as well as the maximum and minimum CPU capacity to allocate for the job as well as part of the parameters in the runner section. Test. The test parameters has three main sections. First is container, which has the container related information. Container URL is the URL of the Docker image which can run the user's tests. N contains the environment variables needed by the container. You will require iteration parameters if you are using sharding. Iteration N key is the key which determines the uniqueness between different test runs. Params list are the list of values for the variable declared in iteration N key. You will need the git section if you are using a git hook on pull request. URL is the URL of the git repository, and you will also need the SHA of the commit and the git token. We support two ways right now to authenticate with Kubernetes clusters. Use DEX authentication mechanism with your LDAP credentials. For this, provide your LDAP username and password and get the DEX parameters from the cluster administrator like client ID, secret, redirect, and the base URLs. Or you can use your own certificates. This is helpful if you have a private cluster. Keep in mind that for any sensitive information, don't forget to encrypt before checking in your Concord workflows. You can use the sharding feature if you want to spin up multiple jobs in parallel using the same image. One common use case is to run your end-to-end tests against different browsers like Chrome, Firefox, etc. In this case, you can do something like this, where under iteration parameters, you can have a key as a browser, and in params list, you can give the array of browsers like Chrome and Firefox. So in this case, the plugin is going to execute two Kubernetes jobs in parallel, each with the environment value Chrome and Firefox for the variable browser. So this is a full example of a Concord flow which uses the end-to-end test plugin. As you can see, I have added the plugin dependency. The task name is E2E test. In parameters, I have runner and the test sections, where in runner I am using the DEX authentication mechanism for authenticating to Kubernetes, and I also have set the limits for memory and CPU. In test section, the container URL is the Docker image URL which can run the user's tests. If your image needs some environment variables to run, you can specify those too, and you can iterate based on the iteration environment key. And once the build is done, in Concord you can look at the overall build status through the build status variable, and depending on if the build status is success or failure, you can choose to continue or hold your pipeline. To view the logs, you can use the kubectl command line utility as shown here. In addition, your cluster administrators can set up in such a way that all the container logs can go to a central logging system, which can be useful for future use and analysis. We have seen some great benefits of using this approach for testing. The sharding feature helps us to run multiple jobs in parallel on Kubernetes, thereby speeding up the overall testing process. The tests can run in a clean and isolated environment on Kubernetes. Also, developers and test engineers can recreate the same setup anywhere using Docker images, which helps them debug the test failures easily. In addition, we provide the hooks to complete the CI/CD workflow. With all this, we utilize our CI/CD resources wisely and unlock the power of Kubernetes. Having said this, we are constantly learning new things and we strive for continuous improvements in our CI/CD process. So this concludes my talk. Thank you all for attending, and special thanks to stackconf on behalf of the Walmart team to put this up together. Auf Wiedersehen.